All right, Tracy, we are live.
Okay, hi everyone. Welcome to the Houston React Developers Group, and thanks for joining us for tonight's event. Just like Fabian said, my name is Tracy, and I'm one of the co-organizers here, along with Fabian, who's also getting us started tonight. Tonight's topic is SolidJS, Reactivity Unchained with Ryan. I will let Ryan introduce himself and talk more about his presentation further once he takes control of the screen. Now, during the presentation, please feel free to enter in all of your questions in the chat, and we'll make sure that Ryan gets a chance to answer those at the end. Before we get started, as always, if anyone has a topic that they would like to present on, or if you yourself are interested in presenting, please click on the link provided in the live event description, and we will reach out to you. Also, please be sure to subscribe to our Houston React Developers YouTube channel and share this recorded event with your fellow developers once it's over. With that, myself and Fabian will go ahead and mute and hide our screens, and we will give control over to Ryan.
All right. Thank you. Thanks for having me. My name's Ryan Carniato. I am the author of a JavaScript framework called SolidJS, and today I'm going to present an introduction to it. What is SolidJS? Well, it's a declarative JavaScript library for building user interfaces. Admittedly, like so many that have come before it. All right. And I wouldn't blame you if you ever took a look at Solid and thought that perhaps it looked a lot like React. It values a lot of the same things: unidirectional flow, read-write segregation, immutable interfaces, and it's really built with a lot of the same building blocks, function components and hook-like primitives in JSX. And it has a lot of similar sounding features: portals, fragments, context, suspense, transitions, concurrent rendering, progressive hydration, and yeah, a few other things thrown into, like custom directives and primitives for data fetching. But all that being said, there's a but, and it's a pretty big one. Solid really is nothing like React. First of all, Solid's built entirely on fine-grained reactivity. That's something similar to MobX or Vue. Its components only render once, and there's no virtual DOM. The whole mental model is completely different. A lot of the same values, but entirely different implementation. So what does that actually mean? Well, modern front-end web development for years has been about components: class components, function components, option components, web components, and for good reason. Components are essential building blocks that allow our programs to be modular and composable. However, in almost every JavaScript framework, they have runtime implications. The update model and life cycles are tied to them, and this has basically led to two views of the world. Either a sort of top-down diff, like a virtual DOM or tag template literal, or alternatively, you rely heavily on compilation. Both of these still have components, though, that kind of update from top to bottom. And this begs the question: when and what to memorize? When you're running something from top to bottom and you want to optimize, you essentially want to make sure you don't redo work. And if you're calling the same things over and over again, you have to look at opportunities to avoid doing that extra work. There is a great talk from Shun at ReactConf 2021 that addresses this exact thing. For example, like take a to-do app, right? We've all seen these before in a framework like React. You might author it something like this. You basically define some state, have a change handler for toggling the to-do, and you map over that list and have a component maybe for the input. But the important thing here is that if you were to ever update something in this component that isn't related to that list, the whole thing reruns again. But maybe that's okay. That's why there's a virtual DOM, to make sure this isn't as expensive. But you still might want to optimize. And as your program grows, you apply your optimizations and things start looking like this. And maybe you add some props coming in from above, maybe add a filter, some sort of theming. There's nothing innately wrong with it. But now we're annotating everything, with memo, use callback, adding our dependency arrays, and ensuring that everything runs exactly how we want it. But it is a bit of a departure from where we started. Well, okay, I know this screen's pretty overwhelming. What if we compiled it instead? And I'm not saying you would ever write this. This is kind of like pseudocode that might get generated. This is from that React talk, kind of a pseudocode for the experimental compiler that the React team is working on. But I want to point out this is not that different from something like Svelte would be doing. A bunch of shallow checks at every decision point that upon rerunning, your component can see what it needs to run specifically based on what has been marked as changed. And you can see that in this code example. I mean, I'm not going to explain it in tons of detail, but there's these memo cache arrays all over the place, and it's checking equality and storing the previous value. So every time we can make sure that it only runs the specific parts you want. But the whole thing here, the reason for all of this complexity, the common ground is that we have a component that when the state is updated, reruns, right? So I posed a question, what if we didn't? What if we only ran what was needed to be run and didn't rely super heavily on compilation? What if the boundaries of our components didn't dictate the performance of our web applications? To do that, we really need to go back to the beginning, though. And I mean really far back to the beginning. Okay, so here we are, hello world. At the very beginning of programming, you probably learned you could set a value in a variable and console log it to the console, right? And it isn't very long before you realize, well, you can change the value of that variable and console log it again. I am going somewhere with this. But this isn't very dry, so we extract it maybe into a greet function, and we can now feel more comfortable greeting our friend every time we change the name. This definitely leads to less code duplication. So this is great, but at a certain point we might think, what if I always want to greet my friend whenever I change the name? So it's probably a good time now to introduce Reactivity, since it's kind of the star of our show here. I love this comic because the answer is also often actually pretty elusive. Reactive programming means different things to different people. That's pretty much it. But so we're on the same page, I will try to give my perspective on it. The way I think about it is like this. A sort of system of live equations, like a spreadsheet. See, a normal assignment represents a moment in time. It means that on the completion, variable A reflects the current sum of B and C. But if either B or C change, you need to do that assignment again. Basically, the relationship doesn't hold. However, with reactivity, it does. A is always the sum of B and C, even as B and C change. So why is that good? Well, it's actually really relevant when we're talking about user interfaces. First of all, it's declarative. Relationships are set once, and then they're executed. It's kind of set and forget. And you get to describe the behavior rather than the implementation. It's also composable. It's easy to wrap up and package behaviors, making them easy to be modularized and reused. But specifically, talking about fine-grained reactivity, which is what I'm covering here and what we use in SolidJS, the most important thing is you only need to know about three things, three simple primitives. Basically, the first one, which is observable state or signals, is basically the atom of data that changes. The second are computed values or derivations. In Solid, we call these memos, which are pure computations kind of built on top of that state. And finally, you have your side effects. And this is where we get to output our data to the world, like rendering. And admittedly, this might sound kind of familiar. You might be like, oh, so React hooks then? It's a fair question. Yes and no. These compositional patterns existed for like a decade before React hooks ever showed up. And actually even in other JavaScript frameworks, things like Knockout.js. It's a little different from React hooks because Reactivity is a system onto itself and has no connections to rendering or components. But honestly, that explanation probably isn't great. I think I'll just have to show you what I'm talking about. The first thing we're going to need here is a new primitive. You can kind of think of it a bit like a primitive bit, like a promise. It's a little API structure that we can reuse, and it's kind of general purpose. In our case, we have something called a signal. And what's a signal? It just wraps over a value with a getter and a setter. Essentially, in our example here, now friend is a function that you call to get the value, and set friend is how you set it. So as you can see in our code here, inside the greeting function, we now actually call name as a function to get it to log, and then we set it. But admittedly, this alone doesn't do a whole lot for us. So we need to introduce our second primitive, and that's our effect. And we define our greeting now. We bring it into our effect, and essentially, this drastically simplifies things. Now, what happens is we define our first signal, our friend, and when that effect runs the first time, it just runs its functions and console logs hello John in this case. But later, when you set friend, it immediately console logs hello Mary. Basically, we've defined a side effect that happens whenever this data changes. We've set a rule that will always be obeyed. And what's really powerful here, and I just want to point out before we move on, is that it's transitive, that we can compose it. That is, we can pull it out of the effect directly. We can make, say, an upper function here that uppercases our friend. And now the effect will display the uppercase version of friend, and we'll still know that when we set or update the name, set friend, to log it again in the capitalized version. By now, this probably looks kind of eerily familiar. Looks kind of like hooks, but it's different. As you see, there's no components here. There's no dependency arrays. So you might be kind of wondering how this works. A compiler, maybe? But no, the answer is actually a lot simpler. This is completely uses the runtime stack. Creating a fine-grained reactive library can be done in about 50 lines of code. Honestly, it's probably easier than the how to implement a promise question you had on your last job interview. I'm going to simplify it even a bit further for demonstration purposes, but it all starts with a signal. At its core, you can view a signal just as a pair of, as I said, a get and set function, or read and write. So as you can see here, when you create it, it returns these two functions back. And whenever you set the next value, it just updates that value, and read always grabs the latest value. Of course, there's a lot more to a signal to actually make it do something. So what we're going to do here is fill in the blanks. Now we've taken those read and write functions, and we've added a bit more code. We now have introduced a list of subscribers, or a set rather. And essentially what happens now is whenever it's read, it gets any current observer. And I'll explain what that means in a minute, but assume if there is a current observer, it adds it to its list of subscribers and returns the value as before. But now when you write, you don't only set the new value, you actually notify all the subscribers. You just iterate through them and rerun their functions. Okay, hopefully with me so far. Now, the other side of this was the effect that I showed off. And the effect kind of runs by using a stack. And you can see this const context at the top, which is the stack. Essentially, the observer is whatever is currently on top of that stack. As you see, get current observer implemented here. And what an effect does is it defines an execute function that it runs immediately. And that execute function runs through the same cycle, essentially. It cleans up its dependencies, pushes itself onto the stack, executes the function that was provided to it, and then pops itself off. I'm going to put both pieces of these code side by side, the signal on the left and the effect on the right. And that's all the code. And I'll kind of run through our example so you can kind of understand a bit better what's going on. Essentially, in our example with our hello friend, we create our friend, our signal, and it returns our read and write functions. Then we create our effect. When our effect executes immediately, it pushes itself onto the global stack. And then it tries to run the function we provided, which was console log upper, right? So what happens is it starts running it calls the upper function, which then calls the friend function, which is our signal read, at which point getCurrentObserver sees that effect on top of the stack. It adds it to its subscribers and returns the value, which then feeds into the console log, which displays it on our screen. When that function completes, the effect pops itself off the stack, and it's done. Then sometimes later, we set the new name, which calls the write function here, sets a new value, and runs through the list of effects. In this case, it's only that one effect, which calls execute again, which pushes itself back onto the stack and restarts the whole process all over again. Essentially, as long as we're doing changes, we just keep on adding the subscribers and rerunning them, and everything keeps up to date. That's really about it. I know it's a little bit heavy, but right in front of you, 50 lines of code, actually a bit less, you have a whole reactive system. And from here, we can build the foundation for other primitives. A lot of them are not essential and can be used as needed, but a few important ones that we have in Solid are create memo, which I talked about before, which is for expensive computations, basically derived state. Create resource, which is a first-party primitive for data fetching and suspense. And create store, which is a proxy which enables us to do deep nested reactivity and only react to specific points of data instead of like a whole object. At this point, I'm going to go back to the demo a bit and actually show you the really interesting part about SolidJS. The thing is, when we teach reactivity, we always use the console log, and I changed the example a little bit here so that it was, a little bit more demonstrative. But you can see we have count 0 and count 1 logging in the corner for our effects. So it's the same example again. We basically have value 0, we create an effect, and we update it. So it logs 0 when this runs and then 1 when we update it. But I propose we do something a little bit more substantial here. So let's change this up a little bit. What if instead of console logging, we make something better, like I don't know, let's make a DOM element for fun. Let's make an H1. And what if our effect instead is just to set the text content of that H1? And to do this, actually, because I'm running in this environment, I'm actually going to clear out the text content on the body because HMR with vanilla JS doesn't necessarily work the best. So I'm just going to do that. And then I'm going to append our H1 to the DOM. Okay. So this is just vanilla JS that I wrote, but you can already see that it worked. I mean, it happened so fast. Like, I'll try to refresh here, but yeah, it happened so fast you don't even get to see it. Essentially, it's already 1. It started at 0, created the DOM element, and this effect updated that one piece of text on the screen here. And essentially, let's do something to kind of illustrate this better. I'm actually going to skip ahead a little bit so I don't have to do as much typing. But let's add a button now so that we can update it like our typical counter app. And it looks like this doesn't keep size between windows. Okay, so all I've done is take what I just wrote, and now I've created a button, and added, click me to it, text, and on click now is where we're going to set our new value. Everything else is the same, except I now append not just the H1, but the button. And this is a fully working counter, right? Because why wouldn't it be? Every time we click, we update our signal, and our signal causes just this little bit of text here to update. Okay. And this is fine, but it's a lot to write. I'm sure you don't want to be writing vanilla JS with reactivity. I mean, this is obviously very performant and a very light layer, and makes it easy to organize stuff, but it's a lot. So what we kind of decided to do here was change it up a bit. Wouldn't it be just better if instead of having to write all this vanilla kind of JavaScript code, we could just use something like JSX? You could kind of picture that we could basically have this JSX with very little compilation difference, just actually compile to these commands. You see button, create element button, children are the click me, and we could probably just take this click handler here and go on click, and essentially still kind of have the same thing, right? Let's see here. Let's refresh, make sure I'm not cheating anything. And yeah, our counter still works because this JSX is just returning vanilla DOM elements, right? We just added a click handler to a DOM element. And we could do the same for our H1, really, right? We could do this, and we could kind of look and see that there's this expression here. And actually, we don't need this right here, so we could do that. And our compiler could go, oh, someone called the function in here. We should wrap it in an effect. And now we don't need create effect anymore. And sure enough, it still updates. But the important thing to understand here is all we've done is just made the syntax a little easier, like a light bit of compilation. We haven't changed how the signals or the reactivity worked. We haven't changed the fact that these are real DOM nodes. We're still just updating that one little piece of text, right? But no one really writes code like this, right? Because kind of modularize and make things easier. So let's kind of wrap up this functionality and pull this up, right? Let's do that. And return maybe an array, H1 button. And what I'm actually going to do is just call our counter function. Again, we're just calling a function here, nothing special. This isn't really like a component or anything. We're just going to spread the results so they go into the append, and we're going to use prettier to format this so it looks not horrendous. And sure enough, our counter still works. But again, no one really writes code like this, so we probably should maybe inline the H1 into an array like this into the button. And then we don't really need to do that anymore. And I don't think we really need an array, maybe like a fragment. And then we can kind of turn this and close fragment. And if prettier knows how to do its job, we should kind of just be pretty good here. Yeah. And I guess the last thing is, I don't want to like text content all the time and kind of do that. So we can make this a little bit easier. We could just go like render, and then it turns out SolidJS has a DOM specific library called SolidJS Web, and we can just tell it to instead render our counter to the document. Okay, and now we don't need any of this, and refresh. And we have our working counter that still only has one effect in it that updates this piece of text. So, I mean, this is probably looking pretty familiar to a lot of people around now. I mean, we've all used React. But things are a little bit different. Things are definitely a little bit different. And the first thing I want to show that's different is I'm going to console log counter in here. And if you've been following along, this will make a lot of sense. But I console log counter and it shows up here. However, if I click this button like 10 billion times, counter never logs again. And the reason for that is because we only call counter once. Like as you saw at the beginning, it is just a function that we called that happens to return some DOM elements that we insert. That happens to have one effect that updates this one little piece of text. That's all that's going on here. So there's no reason why this would ever run again. And I mean, we can get crazy with what we want to do here. We can like try and come up with some scenario that will cause the world to explode. Like, what if we set an interval that every second we update count and have a self-incrementing counter, so it's updating, or I can click it, or it's still updating, click it, and and it still only logs once, right? Because the function only ran once, and we can just do whatever. The world's not going to explode on us. There's no re-render. But our app is still completely interactive and still just updating this one text node. I want to actually take this even further, if you'll allow me, and go, well, sure, this is one function, big deal. But what if we have multiple? Sorry. So again, to save myself a little bit typing, I now took our render function and have 2 counters on the page. No big surprise. And we're still console logging it. And now it console logs twice. So I'm not a liar. We do run the counter once per instance. And that's good because we need to create our signal once per instance so that we have something that, so each function has its own state. So when I click this, it updates, and I click this, it updates. So 2 quote components that update, but they also didn't add any more console logs. They simply defined some state, defined a click handler, and defined one effect to update that one piece of text. And this is basically all there is to it. What's happening here is we actually have closures working for us instead of against us. Essentially, we're just using the closures in these bindings to basically keep a reference. And that way, we maintain state without ever creating an instance of anything. There's no component. It's just a function that gets called once. And I can't emphasize this even more, is we could just take the state out of our component and just stick it up right above both components. And what we've done now is they're now sharing the same reference. We have created global state. It doesn't matter which one of these I click, it updates because it's the same reference, right? We're not doing anything too fancy. We just have a compiler that basically generates some vanilla DOM, one effect for this one header that updates the text, and we created one signal now instead of 2 signals. And I'm going to take this one more step further just to like really kind of hammer it in, because sure, now I have 2 components, but like you're probably thinking, well, what if I have a complicated app with lots of logic and context and passing props and prop drilling and all this stuff? So I've done this for you. I've created an app component now, extracted it out, and now the parent controls the signal, which then gets passed to each counter. So there is shared state going on. But what I've done is that the children passed are essentially, the second one shows double the count, and the first one shows one, like just the count. And then the first one increments the count by 1, and the second one increments the count by 2. We console log in here app, and we console log in here counter. So when we first run, we get app counter counter, right? Because 2 components. And the thing is, even with passing state through components, when I click these, see, increment by 1, 1 and double, and click this one, going up by 2, it doesn't log again because nothing reruns again. It essentially passes the reactivity through all the way to that one effect in this H1. There's only 2 of them on the page, this one and this one. This is the only thing that's updating. You can add as many components as you want on the page, and that's all that's updating. You can add context trees, you can add whatever. That's it. All right. All right, this way. So how's this done in Solid is by only transforming the JSX. For components, when we see an expression that contains JSX or could be reactive, like calls a function, we wrap it in a getter like this. This is the secret here. So if I went back to my example here for a second, this count here for the children is just being wrapped in a getter. And in the case of the DOM, it gets wrapped in an effect. And in so, we push all the evaluation down the tree. Essentially, it's backwards. The effect in the H1 calls props.children, which then calls this getter, which then calls the signal. So essentially, it flattens the tree, and it's all lazy evaluated. We actually only run the code that needs to be run. Of course, this also, as you can imagine, has side effects. And this is sort of the final big thing to understand and know about Solid, is that since we're dealing with real DOM nodes, we have to think a little bit more about places where we do want to say re-render. So I'm going to bring up control flow here, because here's the thing. A map function has no choice but to take input and run through it all and output the rest of it. Like a simple map function, that's all it can do. And in our case, taking some state data and mapping it to real DOM elements over and over and over again would be really not great. It'd be wasteful. Why recreate all the DOM elements all the time? So admittedly, with this kind of approach, you do need helper functions. You do need a specialized map. And we do ship it as a function. You could just go map array, which comes from Solid and passes as a function. But we find it way more ergonomic to use the pattern that we have built into the framework that everyone uses for composition. And that's components, right? This for component actually makes it a lot clearer what's going on. At least it keeps your view together. It pushes the curly braces down. And also in a simple example like this, it's not showing a whole bunch. But the key thing for me is to understand how this promotes composition. And what do I mean by that? Pretend now that we need to update this. Instead of showing all the items list, we want to only show 10 at a time. Use pagination, or maybe a windowed or virtualized list. Luckily, someone has created that component for us. So what do? Well, we just import that component. And it still follows the same pattern. I mean, you do this in React all the time. Lists become paginated or virtualized lists. Conditionals become layouts or suspense or error boundaries. If you think about it, error boundaries are just a conditional. And the big thing here is, if you don't like Solid's for component, it's just a component. Like, write your own. Like, this is not the compiler doing anything here. It is literally just a component. So armed with this, we can actually go back to the beginning, right? I do have a to-do app for you all. And this to-do app is pretty much like the first screen that I showed, where you define some state, define a change handler, and in our case, we see our solid for component here. But this is actually doing the full thing in the last one. It has props theme getting passed down. It has visibility getting pushed into the filter. It has all that stuff. But what you don't see here is there's no dependency arrays. There are no memos, no use memo, no solid.memo, no use callback, no use ref. There isn't any of that. This is basically the original example again. And I've tried my best. This is the hardest part about making this demo, was to show things change, because it's Solid how little actually does. And essentially, basically log whenever we create or update any of the to-dos, whenever the filter changes, or those two things. So if I add a to-do to the list here, now let's actually type something legible, hello. It's just going to call it needs to iterate over the list again to add it. So it calls the filter once, and it calls create update to do, because it needs to get the item, iterate over, but it only updates one of the to-dos, not all of the to-dos, just one of the to-dos. That's why we have that for component. And if I toggle this, well, it doesn't run the filter again. It doesn't need to rerun the list, because you're just toggling one of the items. It only needs to basically update the change handling here. And if this theme, which I'm passing through the parent all the way through, gets updated, nothing logs, because nothing in this component needs to rerun again. Yeah. And that's really the thing here. I call this the reactive advantage because there are no hook rules or stale closures when your components only run once. And when your templates compile to real DOM nodes, well, it's a super low abstraction over the DOM. So like you have this escape hatch. You can always just like reach out and touch it, so to speak. And you have the DOM there. If you need to do something crazy, it's right there. And I mean, sorry, not even crazy. If you just want to like see what's going on, introspect it, it's right there. And most importantly, state updates independent of components. That whole thing I was talking about at the beginning about components being pure overhead. Component boundaries are for your sake, how you want to organize your code, not for performance. The performance is good regardless. Sorry. I didn't silence my phone of all things. Okay. right when I was getting to the good point. So reactivity is just a way of expressing a system of behaviors, and it's not specific to an implementation. You could basically create a whole VDOM implementation inside a single effect if you wanted to, if you think about it. But by treating rendering as a side effect means we aren't tied to a single platform. We can render WebGL or mobile, as well as the DOM, or not render anything at all and just keep some state in sync. There's React Solid State that actually works with React. It's kind of like MobX works similarly with React. And in Solid 1.2, towards the end of last year, we actually added support for custom renderers. And combined with a scheduler, which Solid has internally, Solid is able to implement features like time slicing and concurrent rendering and suspense. In Solid 1.1, we actually added support for interruptible prioritized concurrent transitions. We've been looking at how we can apply the techniques to improve hydration and produce resumable websites as well. Some of you might know I used to work at eBay on Marco, and we actually saw that this kind of sub-component granularity was the key to unlocking performance when the page loads and hydrations. If you've seen the Quick framework, it's actually kind of based on a lot of the similar ideas in that a component is too large of a unit to be responsible for how things update at runtime. And also Solid was the basis for mitosis from Builder.io, which is a compile to any framework library, because when you have simple primitives with simple intent like this, you have the ability to basically model whatever you want. I'm not the only one who's figured this out. If you look at Vue, if you're into Vue at all, Evan has a tendency to basically mix and match features from pretty much every framework, because with his reactive system of Vue, he can do that. I have a slightly different take with Solid, but it's important to understand the pure power of reactivity. Honestly, I'm yet to find anything I couldn't model with reactivity. So reactivity is everywhere in JavaScript frameworks, from state management to compilation, but we can leverage it best if we fully embrace it, live in its declarative world, free from constraints of other render systems and like the virtual DOM, because you can use reactivity in a virtual DOM system, but then it needs to go through whatever diffing and patching that needs to happen. As you can see, we can use reactivity and get right to the text in that one DOM node. no matter how large our app gets. So, I mean, who knows what new worlds are only just a step away. So maybe if you've got some time, give Solid a look. Thank you.
There you go, Tracy. Just turned it on. Awesome.
Thank you. Wow. Okay, just reminding everyone, please, if you have any questions, fill in the chat as those are flowing in. I know I definitely have a couple of questions. While I was watching your presentation, there were two movies that kept entering my mind. It was like that scene in Zoolander where he's like, it's in the computer. Because it's like my brain is trying to step away from React and focus on like, no, this is different. And then of course, Total Recall, he's like, open your mind. Like those were the two that were in my head watching your presentation. It was awesome. Thank you so much. I do have a couple of questions, but I don't want to steal the floor. We're going to allow people to bring in their questions on the chat. Fabian, do you have any questions?
Well, first, I'll go ahead. Can you hear me? Make sure you can hear me right. Cool. I'm gonna go ahead and I guess start on those questions, and then as we kind of wait as they start funneling in, maybe throw a question here and there. But the first question was from Matt. It was from Matthew, and it's something that I'm actually interested in too. Is around so the question is: sounds like Solid doesn't add a synthetic events layer, and I guess just overall, on top of that, wanted to know is like, how are the components themselves, like the actual event handlers, like the on clicks or the on submit, like underneath the hood, is it the same like you would with React, or is there a solid implementation or solid flavor to that?
Yeah, the in terms of events and event handlers, I'd say the system that is closest to us is Inferno. I got a lot of influence from Inferno. Essentially, we do event delegation of important key UI events. Both it's a good performance benefit, but it also helps us for even things like hydration, separating the event from the code running. So we can do cool tricks like capture events before the page is hydrated, and then like decide how to hydrate it and stuff. But essentially, because of that sort of automatic delegation, we kind of call them semi-synthetic. We keep the normal event as much as we can, but we override the current target manually because we're the ones controlling the bubbling essentially. And yeah, I mean, beyond that, it mostly works similar. Like the rest of the events are handled kind of the normal way, but as I said, the UI events category are handled this way, and it has some definite benefits. Oh yeah, I forgot. We also do one other little cool trick because I was really into web components for a while. We also compose it through Shadow DOM boundaries, if anyone cares about that. But anyway.
So Tyler had a question, but I want to come back to that. So John had a good question that, and I guess a preference John. So John's question by saying, it's interesting how the front end history, JavaScript history, how with Knockout, Backbone, I forgot which is the and then from there, and then went to like full on framework with Angular 1, Ember, and then then it went to like UI or just libraries, and then I'm kind of seeing it go right back with Solid, which I had learned going into this presentation, like wow, it's not a library, it's a framework. Things like with like Next or Remix, it was like the framework approach is kind of coming back. So John had a question, is like, what kind of package ecosystem have you seen develop around SolidJS? And that's kind of something that as an engineer coming into web development, being having React being the first thing that they're exposed to, might this is somewhat new to them potentially, where it's like you have to, I don't know if you have to do things a solid way, but there is a solid approach to it. But yeah, if you can speak to that.
Yeah, essentially, we're very much still on the library versus framework. I say framework because I don't. The distinction has meaning, but it has different meaning to different people. So I don't usually get tagged into it too much. I would say we are very much one of those like similar kind of beliefs to React in that we're kind of like there's a core framework and then the ecosystem provides and builds around it, which is hard to be when you're a new player. Admittedly, there's a bit of a tension. I've had to build several libraries myself and like publish them out separately to kind of get the ball rolling. So stuff like the router is actually maintained by the core team, but that wasn't actually my first choice. To be fair. I have always been on that side because Knockout, as you mentioned, was one of my favorite libraries. And essentially, they were just the view model and view right from the beginning. And the React came out and they're like, we're just the view. Well, actually just the component, which is basically the same thing. And like, I've always been a big fan of that approach. When I developed Solid, it was when I was looking at other, I was working in a startup with Knockout, and I really valued modularity, being able to swap out pieces and kind of keep up with the times because we were on a custom setup. And this is something that was very important. That being said, as I said, there's certain realism that comes in. So as I said, stuff like routing and even a meta framework is something being built by the core team. So it's like an official effort, like kind of like SvelteKit has Svelte. We have Solid Start that's approaching beta, which is like our Next.js equivalent. But we still author everything in a very modular, piecewise way, so it can be all used separately. And for us, like the ecosystem is just something that takes the time to grow. But on the positive, we noticed this. We put a hackathon out in December, January time period, and it was a long run hackathon, hoping to give people a chance, to take some time to do Solid. We got an incredible amount of entries. We actually got 3 component libraries out of it. We got Material UI, we got Shocker UI, and we got, I think, Carbon. And the thing is, we actually got 2 Material UI ports, but I think one of them ended up just kind of fading off. But essentially, it was very easy for people to port their React libraries. There's logic differences, but because the templating was so similar, it was fairly easy to kind of get started, like do the heavy lifting. And that makes Solid an interesting place. It's funny, you probably think somebody get so deep on this, but because there are libraries that have React compat, like the ability to be compatible, like things like Preact or like Inferno. And the challenge there, obviously, is they do kind of give something up when they try to be React compat, because I mean, after all, like React is good at what React does. So if you try and do React compat, you need to bring in certain Reactisms to actually be React compatible. And what I saw, over time was those libraries got incredible adoption right out the gate because, it's just like smaller or faster React. It was really easy. But I don't think it helped their ecosystem grow because people would go, okay, yeah, I want this library. And they're like, oh, there it is. There's a React version of it. So then they'd load in React compat and actually build it. And what kind of inadvertently happened by us doing this, even though it wasn't my intention, was people started porting stuff over to Solid. And it's not the libraries we got, but the people. We got the maintainers because they had to do the work. So then now they're maintaining a library. And we've had amazing ecosystem growth for that reason. As I said, getting, UI libraries, getting, testing frameworks, getting a lot of things just coming kind of over from React. And I've said the big one left on the list right now is the meta framework, and taking that on ourselves right now to build our kind of, as I said, SvelteKit or Remix or Next equivalent in Solid Start.
Gotcha. Oh man, it's a long road ahead, but in a good way, a fun, challenging way. So Tracy, I'm going to go ahead and give you the floor to ask your questions. And we do have other questions, but I definitely want you to have an opportunity for, we kind of like talk Ryan's ear off.
So is there a situation where you would have a developer lean more towards React versus Solid or vice versa?
Yeah, I mean, do you want to get a job? I mean, there's no illusions there. React is a great framework. It's used in a lot of places. I think a lot of developers first coming in, might benefit from learning Solid if they want to like learn stuff. I find people who end up learning how Solid works suddenly see React in completely different light, and then it actually like everything makes sense. But that's a lot, you know. So I think to a certain degree, if you want to go get hired, do work in web dev, I think React is a really good choice. I think, I mean, there's just no comparison when you talk about the job market. It's ingrained. Yeah.
And so, go ahead, Tracy.
Okay. My last question, unless Fabian wants to add on to this. No. Okay.
No, go ahead. Go ahead.
My last question, and maybe a little controversial, I don't know, but do you see Solid taking over? Do you see it taking over? I know that's a like you're going to favor that, right? But the reality is, like, do you see it becoming as popular as React, and it's something that people start leaning towards versus React?
Or actually, Ryan, before you say something to that, to tack on to Tracy's question is in the same way. Was it Bamboo? It was Dojo. That's right. Like whenever jQuery, like when that was web dev, right? No one really saw jQuery getting, I guess, dethroned, right? And then, I guess it's not necessarily. I don't want to. Her question, I'll kind of phrase it a little bit differently. Is like, does reactive programming or that approach, because I definitely see a lot of trend with like MobX or the way kind of like how Solid is going, which is very different from what React is. I guess how that is structured. But yeah, like what would it take, and what would maybe be on the other side of that of the hill?
Yeah. My personal thoughts here, generally speaking, are that React is huge, so huge that this isn't, to a certain degree, a question anyone needs to worry about anytime soon. Like jQuery is still, I think it was 2019 when we finally saw the inflection point where jQuery was no longer going up in usage or something, it took over a decade. And yeah, React has easily, like, if they did nothing there, and they're not doing nothing there, I am very into the work that's happening with React right now. Like this is not a question that we have to answer for 10 years. That's the reality of it. Newer players like ourselves, Svelte or whatever, and it's funny I say newer players because Svelte and Solid have both been around since 2016. If people don't realize that. So, I mean, I guess I should say 2018 because I didn't open source it to 18 for Solid. But my point is still, Svelte was around 3 years before it started getting attention. And I guess Solid was open source for 3 years before it started getting attention. Like these things take a monumental effort and time to kind of get to where they get to. And it's not like React sitting still. That being said, I do think there is room for different sort of solution. I think we've seen the genesis of like component frameworks as being the model. I think components taught us a lot and really good. I think we are seeing that components as a runtime mechanism are something less desirable. And the interesting part about that is I'm not sure that's something we'll ever see change in React. I think React will take their model as far as they can take it. So I'm not worried about competition in that sense. I'm actually really excited to see, because like how far they can take their approach versus like how far we can take this approach. And for that reason, I do expect Solid to continue to grow and interest there as we continue to solve, like, this is the starting line. What you can do with technology like this is going to open up different kind of barriers. Because the truth of the matter is, we kind of secretly on the web for a long time, we've been trying to build this DX story, like how we can like build up, make it easy to author apps. Back in the day, you used to have like two apps. You'd have like your Rails app and your jQuery app kind of weaving over each other. And, it was hard to, as things got more interactive, to manage these apps. Single page apps are like, look, you just have to write one app. But what I'm saying is sort of secretly, when you consider the cost of JavaScript, considering the constraints of the network, consider like the environment that the web is, the devices that, different powered devices, different speeds of networks. When you put that all into consideration, we kind of actually secretly just want jQuery output, but author components like React. Like we want to be able to strip out all the extra work, all the extra JavaScript, but still, get to, what's the term, make our cake and eat it too. And I see the approaches that kind of shed away components, which this is my big kind of calling here, as a very good way of doing that. So whether it's Solid or something similar, I anticipate, or at least on this technical side, to be a real avenue. There's other angles that get people into web dev, like Svelte is really looking on the language side, looking at how to make it easy, learning, kind of accessible kind of mentality, and they're going very far in that way. But I think there's still a question on what the best architecture is to build web apps, and this kind of experimentation is happening rapidly right now. So yeah, I expect, it's even happening in React server components and stuff like that. Vue just announced that they have a new experimental compiler called Vapor, which is actually the output looks identical to Solid. It's based on what I showed you guys today. So essentially, and the crazy thing about these technologies, they're incompatible with the current systems to a certain degree. Like they kind of can wrap around them, but they change the meaning of ecosystem libraries and might not directly be compatible with them. So it's like even the big players are right now willing to experiment, losing their whole good chunks of their ecosystem to kind of push things forward. That's why I think they're amazing, that there's people working on it and they're just not resting on their laurels. But it also is a good sign that things are changing. So I don't know if Solid is going to, take over React, whatever. That's the comparison that's really easy to draw because of similarities with the JSX and stuff. But I think things are going to be pretty different in a couple of years.
Gotcha. So we do have a few questions about Netlify, which I'm going to hold off only because I think they just want to know more about you, Ryan. So maybe for sure, if you have a Twitter handle or something, definitely share that, or we'll include that in our follow-up email to the group. But one question I did have is I wanted to ask you, just like how React developers can shoot themselves in the foot with unnecessary re-renders, or the misunderstanding of unidirectional data flow and how they should set state or update state. Are there any gotchas like that with Solid, where someone who doesn't know, it's a hard lesson to learn until it finally clicks? Is there anything like that people need to be aware of?
Yeah, you saw the reactivity and all the lazy access in my video, and sorry, my talk here. And the key there is, it means that Solid has one rule. I call it, it's like the one rule, and you'll probably hit it at the beginning in a number of places, but it's all a form of the same one rule we have, which is essentially you have to be careful not to lose reactivity, as in don't destructure your props. This is the one that gets people, because in React it's become, especially with function components, very, very, very common to destructure your props. But what destructure your props means is you're calling those lazy getters at the top of your function instead of where they're being used. There's no way to actually take advantage of that information. We'd have to re-render the whole component if we were going to do that, and that would not be good. So that is the rule, essentially, is that because stuff runs once, because you're basically just constructing things declaratively that get returned, right? You can't just access stuff out in the open. If you want to use props, put them in an effect, or put them in the JSX, or even just wrap them in a function that you call in an effect or in the JSX. But essentially, you need to be at least aware that this reactivity is something that kind of flows through the app. That's basically the gotcha. There's no stale closures. You don't have to worry about the counter that stays at 1 forever, and there's no incessive over running of stuff in why is this running or whatever. But you'll build your first Solid app and you'll be thinking like you do with React, and then you're just like, why is this not updating? And then you'll come to the Discord and you'll post it in help, and then you'll read what you posted and you go, oh, you'll realize the second you posted it. It's that kind of level of thing. It's very easy to see once you're looking for it, but when you get caught up with stuff, it's very easy not to see it. You know what I mean? And everyone's going to hit this at the beginning. Everyone.
So John, and so this we're gonna wrap up with these two questions. Another question from John. I'm gonna go ahead and combine both of them. The first question is around memory leaks, which is something that I was curious on, specifically around the. I think it was in the observer. Whenever like you did the try finally in that code, and I didn't know how to frame the question, but I'm glad that John's asking it here. And then the second question. So in regards to like memory leaks, what type of, and this from John, as far as the tooling, extend Chrome extensions, IDE extensions, things that kind of help like the developer experience. If you can speak to that, and where Solid is and where you would like to see it go.
Yeah. Okay. Yeah. First on memory leaks. One thing I didn't cover, and one of the key differences from something like MobX, which was actually made this really well suited, and I actually got this from a library called SJS. That was around about 2015-16 time period, is that we actually not only register subscriptions that we clean up, but we also register any computation, like a create effect or create memo that happens under, like I didn't show it here, but you can nest effects and effects and effects and effects. Like you can nest them like 12 layers deep. That's actually how the renderer works. Essentially, it's a bunch of nested effects, like because then only the closest one reruns. And because everything starts from that singular root and they all connect up, essentially anytime that anything reevaluates or reruns, it basically cleans up the memory of all its children. So a lot of times if you use reactive libraries in something like React, you'll be in that situation where you're like, oh yeah, now I have to dispose of the subscribers, or maybe the hooks take care of that for you under the hood. But generally, like essentially we use the reactive tree of creation of like putting them inside each other nested, both to handle cleanup, and that's actually what our context API leverages. Like, so instead of leveraging components as a way of doing context, we leverage these reactive expressions. And essentially, if you think about it, reactive expressions are decision points, essentially. So you'd only nest effect in a situation where you're like, oh, this branch or this branch. So instead of components being the level of like change, it's actually the control flow in your app that's the level of change. And yeah, so it all just kind of auto wires and auto disposes. So that's like basically the whole thing. We actually, if you try and create reactive stuff outside of one of these, we throw a warning at you. So you'll know, like if you decide to be an event handler and like create effect or something, it'll be like, hey, this is never getting disposed if you create it out here. Yeah, that's a thing. In terms of tooling, this is a place that obviously needs work because no one's really, I shouldn't say, Knockout was a framework that was kind of like this. It used the HTML data binding parsing, and it was a little mechanical, but it's been a long time since we've seen a framework that actually uses fine-grained rendering like this. It's since basically before React, and the tooling has completely changed during that time period. So we've had to rethink how tooling works, because like we don't have components, like not really. So we actually in dev fake components by adding extra inert reactive wrappers so we can like do a bunch of stuff. So this is an area that like some people made a few browser tools like kind of inspect parts of the graph, but even figuring out how to visualize this is a problem that we're still trying to solve, because there's different types of informations and things that are useful. We're finding for the most part, if we try and model things as close as we can to React, like give people a component and show them the props and their state, it's kind of agreeable, but it's still like it's not really how Solid works. So like we're trying to like figure it out. Like you can always debug the reactivity. Like you can plug a Solid store into like Redux toolkit, or sorry, the debug tools, and actually like play that game where you can actually use that to see things if you want. But generally speaking, it's not like, since the reactivity runs through our whole tree, like our whole rendering, it requires a different kind of tool. And this is something, it's like if you look, it's like the oldest open issue on our GitHub. Like we've been doing a lot of research into it. In terms of other kind of tooling, like quality of life stuff, like in the IDEs and stuff, well, we have a great advantage on our hand of using JSX. And and this is actually the reason I used JSX originally. I love JSX now because of how portable it is, how you can just like make a div here, make a div there, throw it around, like I was kind of showing. But the reason I chose part of the reason I chose in the first place was because Babel already had AST parsers, so I could make my custom transform. ESLint, Prettier, like TypeScript. These are things that we get almost for free. Like we didn't have to make a special language server. We literally just use the stuff that everyone uses with React for this kind of stuff. So that was a huge benefit. We just have to provide our own JSX types. I think the biggest boundary is we do have a custom compiler for JSX. So like you do need Babel right now. There's been some work into SWC, and Jared even made a bun solid compiler one day when he was bored, a couple days before he decided to release. Guy's crazy. But stuff like this is in the works. So I see more potential in the future. So for the end user tools, though, for the most part, linting and Prettier and TypeScript and VS Code and completion, all that stuff just kind of works out of the box.
There we go. Gotcha. Sorry. And so, okay, with that, I'll go ahead and we'll wrap up with this last question. I don't mean to sound like Sean Evans from, Hot Ones, that wing eating show, but I mean, what's going on in your life, Ryan? Like what's latest and greatest? What are you working on with Solid? How, what's going on with Netlify? What's is there anything big that's, on the horizon for us to be, looking forward to?
Yeah, I mean, the big thing here and the timing here of joining up with Netlify and working on Solid, I guess full time currently, but really it's an open source full time kind of thing. But right now, a lot of my focus on Solid is Solid Start, which is the new meta framework that we're working on, like SvelteKit and Remix. It basically combines a lot of those pieces. We've been working on it for ages. I started working on it basically when V2 was released, so like February 2021. I haven't moved it to beta now. I'm a bit of a perfectionist. It took me like 6 years to get Solid to 1.0. This one will be faster, I promise. But essentially, we are getting very close to our beta release. And yeah, I've got some great people working on docs, working on Solid Start itself, and we're really excited about it because, as I said, we've taken some of those aspects that are very unique about Solid, its granularity, and then kind of mixed it up a bit with a lot of concepts like progressive enhancement and forms like Remix and I guess nested routing and stuff. We've always done the nested routing data loader thing, but essentially a lot of kind of elements like that and inspiration from SvelteKit in terms of non-hydration routes and stuff like that. So really finally having a vehicle where we can just point at one project that people can just go with. It actually, the way Solid Start works is it actually, what you can choose whether you want it to be a client app, kind of think like CRA, or a SSR app, and it actually generates almost identical bootstrapping. And you can literally just switch SSR true and switch back and forth. We have special features for SSR, but it was really important to us that anyone coming in could just basically take any project. We've been using Vite, for example, when just de-getting templates for our starters the last year. You can almost just drop that in, kind of upgrade to the file-based routing, and then if you choose, it's all the same libraries you've been using with Solid, switch it to SSR and take advantage of that. It's basically almost a very smooth transition. So I'm very excited for when that becomes reality, because we'll have a single place to be like, you want to get started with Solid? This is how you do it.
Perfect. That's awesome. I'm glad I asked that question. And actually, I think, Tracy, we're going to start asking that question a lot more, because that's a really good something for me to keep an eye on and actually just play around with. But cool, Tracy, I'm going to go ahead and hand it back over to you if you want to go ahead and wrap this up.
Yeah, thanks, Ryan. Thanks again. This was awesome. This was eye-opening as far as, what's out there and what other people can be trying to use. Yeah, I mean, this was amazing. I don't see why we wouldn't have you back, especially if you have these major updates that you want to share with everyone. That would be great. We'll definitely, stay in contact with you for sure. But I think that is it. Thanks again. I really appreciate your time tonight, sharing this with everyone. And yeah, hopefully we'll see you again in the future.
Thank you. It was a lot of fun.
All right. With that, thanks everyone for joining us tonight, and we are going to sign off.
All right. Bye, everyone.